Hi, it's Grayson and Danica, and we're covering Unit 2, Section 6, Discontinuities. In order to understand if and where a function would have a discontinuity, we first have to know when a function would be continuous. The three characteristics for a continuous function is 1, a is in the domain of f, 2, the limit as x approaches a of f of x must exist, and 3, limit x approaches a fx must equal fa. If a function does not meet these requirements, there is a discontinuity somewhere in the function. There are three different types of discontinuities. One is infinite, which would just be an asymptote. 2 is a jump discontinuity, when the function jumps from a different y value on the same x value. 3 would be a removable discontinuity, which would just be a hole. These are just examples and what they would look like. X equals 1 is infinite, it's this asymptote right here. As these approach this, it never reaches it. X equals 2 is a jump discontinuity, where you can see they jump to a different y value on the same x value. And x equals 3 would be a removable discontinuity, it's just a hole.
For our first example, we have been given the function f of x equals 2x plus 3 if x is less than 0, and x squared if x is greater than or equal to 0. And we are asked to determine the points of discontinuity. In order to do this, we need to set the functions equal to each other. Next, we are going to rearrange the function. Using this function, we'll factor it out to find our points of discontinuity. This leaves us with our points of discontinuity.
Our second problem is, given the function fx equals 1 over x, identify the type of discontinuity. So this function is over x, and we know that anything over 0 is undefined. And so that means where x equals 0, the function is undefined, which means there would be an asymptote at x equals 0. So it would look like, what did it do? To prove that there is an asymptote in this equation, plug in 1 over x and graph it, and you'll see that none of these lines touch 0 as they just continue to go up and on the side.
For our next example, we've been asked to simplify the function f of x equals x squared minus 4 all over x minus 2, and to determine the location of the hole in terms of x. To do this, we need to factor the numerator first. Next, we're going to simplify and cancel these out. This is all we're left with, meaning our hole is x equals 2.
For this next problem, we have identify the type of discontinuity and explain why it exists and draw a graph. For the function we got is absolute value of x over x. Well, we know in terms of absolute value x over x, the top value has to be positive, while the bottom value could be either positive or negative. But however, x cannot equal 0, as we already know, because 0 cannot be divided by. So that would leave where x equals 0, the function is undefined. In this function, x can be any coefficient besides 0, because x is in the denominator, which, what? The second part of the question says to explain why it exists. Well, we already know why it exists. It's because x cannot equal 0 if it's in the denominator, otherwise it's undefined. To draw a graph, or to identify the type of discontinuity, we have to draw a graph. And that's because this x could equal any coefficient besides 0, and it would either equal positive 1 or negative 1. Because if x is less than 0, then it has to equal negative 1. And if x is greater than 0, fx has to equal positive 1. So the graph would just be like this, say that's 1, I guess, and then negative 1 would be down here, and then like that. And then there'd be a disconnect here, which would make it a jump discontinuity. So this function would be a jump discontinuity because x cannot equal 0, but it can equal anything above or below 0. So if you put it into the calculator, absolute value of x over x, and you graph it, there's this disconnect right here.
For our next question, we've been asked to analyze the behavior around x equals 0 for f of x equals sine 1 over x, and to identify the type of discontinuity as well as the location. The graph here represents our function, which as you can tell, does not equal 0 and cannot. This means that at x equals 0, we have jump discontinuity. For our last question, we are being asked to determine the points of discontinuity for f of x and to classify each discontinuity. Here we have f of x equals sine x over x. Because in functions there cannot be a 0 in the denominator, the function has a discontinuity there. However, in order to determine the type of discontinuity, you have to differentiate. Differentiating gives you this. This limit proves that the limit exists, but is undefined as 0, making it a jump discontinuity.